hey Bilal, what's up?
What's up, Ian? Dude, Ian, I don't get how playing pool works. Like, I hit the ball, and the ball I hit stops, and the other one keeps going.
Oh,
Like, how's that even?
well, let me explain. When talking about pool, the main thing we have to consider is that the balls collide. Follow me. There are two types of collisions, inelastic and elastic. And when playing pool, the balls experience elastic collisions. An elastic collision is a collision where both momentum and kinetic energy are conserved. An inelastic collision is where momentum is conserved, however, kinetic energy is not.
Ian gave me all this wonderful information, but I still have no idea what momentum is. Who's gonna help me?
Well, Bilal, momentum is a vector. More specifically, momentum is mass times velocity. We say mass times velocity because momentum has a direction.
Alright, so this is Bilal again. I'm holding a camera now, but I still have a couple questions for you, Ian. First of all, you showed me all of this, all these explanations and stuff, but I need to see it like demonstrated. Can you do that for me?
Sure, Bilal. So, when the white pool ball is hit by this pool cue, it will be given a velocity and a momentum. When this pool ball continues on a path to hit this pool ball will stop moving, but this pool ball will continue with the same momentum that that pool ball once had.
I see. It all makes sense now.
The measurements that are going to go into this demonstration will be the velocity of the balls as well as the mass of the balls. We know that each one of these balls is 0.16 kilograms, and we know the distance between each one of these balls is exactly 1 meter.
Alright, so to find the velocity, obviously we're going to take the distance and divide that by the time. And then to find momentum, we're going to take that, multiply it by the mass. So the distance obviously is 1 meter. We're going to time the time it takes from this ball to hit this ball, and then we're going to multiply it by the mass, which is 0.16. Alright, one thing we have to explain before we start this experiment is that this ball should hit this ball and stop, but it might hit the ball on an angle, which will cause it to spin off.
And it begins. Okay.
Alright, so as you saw in the last 3 trials, it was less than impressive in the sense that the ball didn't stop. Obviously, we explained it earlier, they hit on an angle. Now I'm going to show you what happens when they do hit directly at each other. Alright, we'll use that one.
After calculation, we found that the first ball's momentum was 0.243 kilogram meters per second. And the second ball's momentum was 0.253 kilogram meters per second. As we can see, the momentum was conserved because they're extremely similar, and thus demonstrating how pool is a very good example of elastic collisions.
Wow. You just blew my mind. Now I can use this information to destroy all my teammates. Thanks, man! I'm gonna win that bet. You're going down. Someone who I know.
Alright guys, one final thing to add to this experiment slash video is we talked about the outside forces being insignificant, and it showed that through our calculations being almost showing that it was almost perfectly elastic collision. But one reason, and I think the most important reason why we didn't experience completely elastic collision, is due to this surface right here. As you can see, it's it's felt, and this would cause friction, which would cause the ball to slow down. So although our calculations brought us very close to completely elastic, the friction obviously slowed the ball down a little bit. Alright guys, just talking about our calculations, the way we got it was we used a scale. The only problem with using this scale is, as you can see, the red is kilograms. But since one ball is so light, it was very difficult to use one ball, so we had to use 14 and divide that by the weight of in kilograms to get one ball. Obviously, there's only a few balls here because we used them in our calculations. Another thing we have to take into account is the edge of the table. As you can see here, it's dipped, but if you measured it under, you can see my hand, if you measured it under there, that wouldn't be acceptable because the ball doesn't hit under, it hits right there. So you have to measure from there. If you guys didn't realize this, obviously it's not calibrated, but I guess you could say that we just said 0 was where the arrow started at with no weight.